I'm Caroline Dive. I'm the Deputy Director of Cancer Research UK Manchester Institute. I run the Clinical and Experimental Pharmacology Group at the Institute, and I'm building a biomarker centre, so at the Manchester Centre for Cancer Biomarker Sciences. So the team is about 87 people now. It's run in various ways. We have a preclinical pharmacology team testing new targeted therapeutics in patient-derived mouse models. We have a cells and proteins team, which measures circulating tumour cells. It measures proteins in plasma from blood samples. And we have a nucleic acid biomarkers team that looks at circulating free nucleic acids in the blood, also single cell profiles, those circulating tumour cells. So a big emphasis for us is liquid biopsy. So what can we learn from a cancer patient from a 10 ml sample of their blood? Now, of course, to do that well, we're generating a wealth of data, genomic data, proteomic data, enormous data sets. And a challenge in the past for clinical trials where we measure biomarkers, either in the tumour or in the blood, has been how rapidly we can integrate the science with the clinical characteristics of that particular patient. So whilst the busy in the lab, busy in the clinic, bringing those data sets together has been a challenge. So I'm absolutely delighted that the Digital Experimental Cancer Medicines team has joined our biomarker centre, because they really sit between the clinic and the lab and allow us to integrate all that information in real time. And I think the other thing that they do so wonderfully is involve the patient far more in the trial process, which I think is something that really distinguishes, this innovation really distinguishes us as a cancer biomarker centre. So a perfect example of how we work together with the clinical research team is that we work on something called the target trial. And in this trial, we take tumour biopsy, we take blood samples from patients entering the phase 1 clinical trials unit at the Christie. What's really important is when we can't get a biopsy, or we can't get sufficient biopsy to profile the molecular signature of that tumour, if you will, we can always get a blood sample. So what we're doing in the target trial is comparing the molecular profiling in tumour biopsy when we get it, and the profile of that circulating free nucleic acids, tumour-derived, in the blood sample. And we can look at those data sets together and help the clinicians make decisions about which patient should go on which particular phase 1 clinical trial. And what the clinical research team have done is generated this wonderful virtual molecular tumour board. So the clinicians, the scientists, the bioinformaticians, the research nurses, the project managers, the professional genetic counselling, that can all come together every 2 weeks and look at the data from the tumour, look at the data from the blood, look at the clinical data, and put it all together in a virtual molecular tumour board. And one of the reasons this is so important is busy people all getting together physically in a room at the same time is a real challenge. So what we can do now is we can sit in our office, e-target, which is what the clinical research team have developed, is brilliant. It goes up on the screen, I can sit at my desk, and the molecular biology, the tumour data, the blood data is all on the screen. The clinical characteristics of the patient are all on the screen. We're typing in real time, it all appears on the screen. And so these decisions about which trial this patient would be best suited to can be made right there and then. So that e-target is a perfect example of why it's so important that the work that this team, the Digital Experimental Cancer Medicine team, are doing, how they really contribute to the overall holistic goals of the Biomarker Centre. So I'm delighted that they've joined us. I think we're doing things that other people simply are not doing, and I think it's become the envy of the world, actually.